Hello, welcome to Unified Science Lab. Today we are going to solve example under a moving coil, and the question says a moving coil ammeter has a fixed shunt of 0.02 ohms with a coil current resistance of 1 kilo ohms and need potential difference of 0.5 volts across it for full scale deflection. And the question 1 says, to what total current does this correspond? And the number 2 says, calculate the value of shunt to give full wave deflection when the total current is 10 amps and 75 amps. So we are going into the formula, the solvings now, which is solution. And I would like to write out the parameters that is being given there. Given that. So according to the question, these are the parameters that is being given. I want to solve the first one now. To what total current does this correspond? To this where is it? The shunt resistance is being given to be 0.02, and the resistance is being given here to be the current resistance is being given here to be 1 kilo ohms, which is 1000 ohms, and the voltage is 0.5. Then doing the solvings, we have the formula Im is equals to V all over R, which is V is the voltage here is 0.5, and the current, which is R, is 1000. And doing the normal calculation, the Im is equals to 0.5 divided by 1000. That will give us 0.0005 amp. Remember, current, this is a unit for current. We are solving for the Im. So the question was, what total current does this correspond? So to have the total current, the formula to have the total current will be the I total is equals to I shunt plus I meter, is Im. That's it. So now we have solved for Im. We need to solve for Is, which the formula to solve the Is according to this Ohm's law. Ohm's law says voltage is equals to IR. V is equals to IR. So V, we know V to be 0.5. Do I need to write this again? Let me just write it well. I is R is V is 0.5, and I is here is not being given. We don't know I is equals to I is times R shunt resistance is being given to be 0.02. So make I is the subject of the formula. So then you have I is equals to 0.5 divided by 0.02. That will be 0.5 divided by 0.02 will be 25 amp. Now, since we have the Is and the Im, we now solve for the total current. The total current is I is equals to I is plus Im. I here will be equals to, we know I is and we know Im. I is to be 25 amps plus 0.00005. That will be the total current here will be 25.0005 amp. Approximately I will be equals to approximately 25 amp. Now we have solved for we know the answer for the first question. Now let's move to the second one, which is calculate the value of shunt to give full scale deflection when the total current is 10 amp and 75 amp. So we solve for the first one, which is 10 amp. Solving for the first one, which is 10 amp, we first write the formula. Since we are looking for the shunt, the RS, or you might write normal is like shunt is equals to IM times RM divided by I total minus IM, knowing that the I that is given there is 10, the total current that is given there is 10. So if you fix in the formula, the first one you have solved for IM and RM, then you look for now fixing this IM, which is 0.0005 times 1000, which was RM here, RM divided by 10, which is the total current minus 0.0005. The answer here will be S will be equals to 0.5 divided by 9.9995. So S or RS will be equals to 0.050 ohms. This is how to solve this particular formula in case you come across it in exams or in test hall. Just know the formula, others are simple. Then solving for when the total current is 75, I is 75 amp, and that will be just fixing there in the formula, which is S is equals to IM times RM divided by I total minus IM. That will be just substitute the values there in there. So have 0.8 is equal to 0.0005 times RM is given there to be 1000 divided by the I total here is 75 amp minus the IM 0.0005. So S here will be equals to 0.5 divided by 74.9995. So S will be equals to 0.00667 ohms. This is the final answer to the question that was given here. But if you want to convert it to milliamps, you can still do it, or microamps, how you want to convert it is okay. But I would like to leave my own this way. In case you see it in exams, or just fixing the formulas and just know the formulas to solve it. And I think I should make a video on how to derive the formula that I'm using to solve this. I'll try and do that. Thanks for watching.